Hello, YouTube audience. Mathematical Platonist that I am, I have a little ethereal light just to make this look mysterious and awesome. But actually, I want to talk about something very concrete. I want to talk about the objections to... Now, this is a part of a series of videos, most of which are purporting to show that the continuum hypothesis is true. So if you're just logging on to this, you're going to have to go up to my YouTube identity and go over to my very first video series where it talks about my argument in favor of the continuum hypothesis. Now, I've made a few videos on some other subjects, but I'm basically returning to mathematical philosophy at this point and trying to affirm Cantor's arguments in favor of the continuum hypothesis. Well, the literature seems to cite this particular article here, and I've imbibed many of its arguments by reading on the computer. Logic of Actual Infinity and G. Cantor's Diagonal Proof of the Uncountability of the Continuum by a Russian gentleman. I'll assume he's Professor A. Zenkin. I'm going to assume he's a professor. If he's not, I'll use it as an honorific title of respect. I assume he's a logician or a mathematician, something perhaps... it's a little unclear, or perhaps a philosopher, but he takes issue with Cantor's entire argument. In fact, to be really honest with you, he seems to want to resurrect Aristotle and the idea that infinity is potentiality and not actuality. And so if he's right, then Cantor, in fact, he'll even turn Cantor's diagonalization proof around and claim that it actually disproves the whole idea of infinity by leading to a contradiction. So obviously this is some kind of hurdle to overcome. I want to start off by stating that I consider the whole potentiality-actuality argument to be a false dichotomy. If we consider, and again, I must state for the argument, I am pro-Cantor, and so this is going to be my attempt at a refutation of at least some of his arguments. The beginning with his major premise, and that is the potentiality-actuality distinction. Now, if I consider the number 5, and I talk about 5 equal quantities of something, equal weights, equal measures, equal something like that, am I talking about potentiality or actuality? What am I talking about? When I talk about equal, I'm talking about not even a Planck's constant of difference. I mean, absolutely equal quantities, equal weights, equal measures. Am I talking about potentiality or actuality? Well, I mean, we don't have absolute equal anything in nature. That's an abstraction, as it is. Okay, so we've constructed the number 5. I mean, in a sense, you construct it using piano arithmetic. I can't pronounce. Piano arithmetic. Sorry, Italians. Or you can just construct it in your mind. But either way, there is no potentiality-actuality distinction that I can really think of with the number 5. Either you accept the Platonic definition of 5 or you don't. Now, if you do not accept mathematical Platonism in any sense, game over, and I'll have no real argument with you. We disagree on a fundamental premise. But if you do accept mathematical Platonism, but you say that only the finite exists, quote unquote, then there's a problem here, and that is even the finite is you can't really make a potentiality actuality distinction with the finite. I mean, either 5 is the same 5, whether it's 5 apples, 5 trees, 5 stars, or just some abstract number 5, or it isn't. Now, in the case of infinity, you can argue, and he does argue, that, well, the finite never gets to the infinite, and if you have an infinite series that never terminates, you just have an infinite series, a finite series that never terminates, you just have a finite series that never terminates. But what I would question him on, though, is that the whole idea of never terminating, well, you wouldn't say it terminates at infinity. That wouldn't be technically accurate because it never terminates. But what you would say is that the never aspect of it means that it is not finite. In other words, you have a set that already is not finite. Therefore, it is infinite, not finite. Okay, so again, anything in mathematics, potentiality and actuality don't make any, there's no distinction. If I have 0.9999999 going forever, and I ask myself, well, when will it reach 1? Well, we know that it converges onto 1, and we know this mathematically. 0.99999 forever becomes 1. It can be proven that it becomes 1. An actual series, 9 tenths plus 9 hundredths plus 9 thousandths plus 9 10,000ths going on forever, will converge on 1, okay? But it will not do it on any finite length of time. It is infinite. And so it never reaches 1 from the perspective of the finite. But remember, the finite is as much of a construction as the infinite. Both are constructible mathematically. And therefore, from the standpoint of mathematics, both of these exist. And so, right off the bat, I have a fundamental philosophical disagreement. Now, he's a professor. He's financed by the Soros Foundation, which is a little bit interesting. I'm not quite sure what that's all about, but that refer to, we won't go there right now. Okay, you can see some other videos on Gödel and some of my political videos. But anyway, I want to also get to an actual specific argument that he made, which is he used a hyperreal, and the hyperreal is wide. Oops, there we go. Okay, there we go. I might have to make a part 2 to this to really encapsulate my whole argument. The hyperreal is a number that on the surface of it doesn't make any sense. Y1 is equal, and this is something he invoked, not me, okay? Y1 is equal to point Y12, point Y13, I'm sorry, point Y12, Y13, Y14, Y15, dot, 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 Y11. Well, when I first looked at this, I said, well, wait a second, that cannot be a transcendental number. That is a finite number. And not only that, you're treating these as nominals and not as either ordinals or cardinals. Okay. So, at first it didn't make sense, but then I realized, it was explained, okay, he's talking about a hyperreal, where it's basically a number with its order rearranged. And so what this is actually equivalent to is this. Y1 is equal to 0.12, 13, 14, 15, dot, 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 plus Y11. Okay. Well, right off the bat, he still loses me because, the 0.12, 13, 14, 15, dot, dot, dot is now no longer an actual number that exists. You're now again treating your Y series there as nominals and not really as cardinals or as ordinals. But no, okay, I'll play along for the sake of argument. I'm trying to get to what he's talking about, but he's claiming that the diagonalization argument, well, he's claiming up here that the diagonalization argument doesn't work. Okay, it doesn't work because now it only works for numbers in proper order. So once you've established that you can rearrange the order of things, well, the diagonal argument isn't going to work. But actually, if you really break it down, what it really means is if, an argument can't be constructed if you can't arrange your paper correctly. Sorry about that. It really means this. Y1 is equal to point Y11, Y12, Y13, Y14, Y15, dot, dot, dot. And, the diagonalization argument works just fine. Up here, it's not going to work the way you have it. You would have to do the diagonalization, a different way. You'd have to start with Y11, and then you'd have to, let's say you have Y2 is equal to Y22, Y23, Y24, you'd have to just start from here and then go over to here in your second row, and then, well, you wouldn't have a diagonal, you'd have a zigzag, but I mean, it would be the same basic idea. You've just, the diagonalization argument is not dependent on it is not refuted by hyperreals. It would only be refuted if you treated these numbers as being nominal instead of as being ordinal or cardinal, but then you don't really have a number that is constructible. You have some abstract mathematical argument that has nothing to do with, actual cardinal numbers or real numbers. Hold